The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Just going to ask. I'm going to ask you to hold off on questions mostly till the end of the presentation, anyway. But if someone could just hit their little raise hand icon, if you can see the welcome screen on your machine, should be saying welcome, and when we start, I'll ask everyone to raise their hand, etc. Okay, good. I see that. Excellent. And I will just see if I can't drop everyone's hand. There we go. Thank you very much. All right, welcome. So we're going to talk about, my name's Greg Trasick, by the way, and we're here to talk about the top 10 trends in IT in 2016. And I'll just mention, hopefully, yeah, there we go. Top 10 trends in IT in 2016. Source of these trends, you can sort of Google around yourself and find any number of lists of trends. A lot of them tend to come from Forrester and Gartner, and I've tried to avoid picking up on those too much, mainly because I think sometimes they're thinking a little too far out, and also I sometimes wonder if they're promoting some of their customers more than anything real. But I've also tried to um, sort of inject a little bit of insight that I get from our customers and a couple of things that uh, I've seen coming up that sometimes surprise me and sometimes don't. But I start seeing, when enterprise customers start asking about things, then I know that something is real. So we're going to talk about cloud, a couple of trends that I see: cloud-focused computing and containerization of cloud computing. DevOps, the very existence of DevOps is an upcoming trend. Now, DevOps itself is a couple of years old, but what I've noticed in dealing with our clients in the past, 6 months to a year, is that the idea of DevOps is really hitting the enterprise, and people are really beginning to embrace the DevOps. So it's kind of left the Silicon Valley startups and started to get into corporate mainstream. We'll talk a little bit about mobile. Mobile is obviously not new, but I think there's a couple of trends that are worth noticing. First is mobile first apps. There's now, I think the default to an application really has to be that we're going to use it in a mobile way to begin with. Along with that, we're really beginning to see an explosion of enterprise mobile apps. We've kind of had, and at WebAge, we've been teaching mobile development for years, but it's always been sort of limited to the folks who are either on the front lines of customer experience or sort of the almost retail-oriented consumers. And what we're really starting to see is a trend towards embracing mobile for access to enterprise data and access to sort of ongoing operational data and transactional support, the sort of business processing support that traditionally has been the realm of traditional web apps and desktop apps. We'll talk a little bit about the Swift language, Apple's Swift language, which was released a couple of years ago. But what's starting to make waves about it is the idea of using it not just on Apple devices and beginning to move it into server side and possibly other devices as well. We'll touch on a couple of things in big data. Apache Spark is a product that is beginning to get a lot of interest and hype, and as an alternative to sort of batch processing Hadoop clusters for big data and sort of traditional MapReduce systems, stream-oriented processing. We'll talk a little bit about the Internet of Things. This is one that shows up really heavily on the Gartner and Forrester style top 10 list. Uh, we have some interesting comments on it. I'm not quite convinced that the Internet of Things is quite there yet. I think it's kind of a solution looking for a problem, but it certainly is coming out into the real world in a big way, and we'll discuss that. And then finally, agile development. The idea that agile development and lean software thinking and lean thinking in general is not just for software development. And I'll throw in a little insight there, which is that it wasn't just for software development in the first place. The whole thing comes straight out of production and operations management. But certainly the thinking of lean and the thinking of even to some extent DevOps thinking and agile development. The entry point into the enterprise, surprisingly, was not production and operations, but through software development. And as a result, we're starting to see more adoption and embracement of agile and lean in other business processes. Okay, so first off, cloud-focused computing. And, again, cloud is not a new thing. What I think, though, is new is the embrace of cloud within the enterprise. And as you may know, a lot of ideas sort of start out in smaller companies, sort of leading edge, Silicon Valley type companies. And the startup sector was the first to embrace cloud computing in a big, big way. But what happens is that after a few years, these ideas sort of suffuse into the enterprise, and that's where most of us are working. And, I know things have been hitting mainstream when I start seeing enterprise clients asking about it. And cloud is one of those things. And, to give you an idea, I knew when cloud arrived because of a story that happened, I don't know, 6 months ago. But it sort of dates back to, I'll tell you a story. About 15, 16, I don't know, 17 years ago, something like that. I was looking at starting up a new company, and I had this idea. The internet was just beginning to become pervasive. Internet was just beginning to become pervasive, and what I was looking at doing was using cloud. Really early software as a service, early platform as a service, and the idea was to let small manufacturers and so on handle their shop supplies. And the idea was we'd put a barcode reader at the tool crest. I don't know why that keeps auto advancing. It's really not supposed to. Anyway. The idea was that we'd put a barcode reader in the tool crib so that you need a package of bolts, you go scan it right there, and it automatically gets replenished. And I went and talked to, I don't know, half a dozen vendors or potential clients, and inevitably the universal answer was, well, security. We can't let that data be hosted externally. We need to have our data hosted internally. And, I tried to convince people that, we actually can do security. We can password protect it, and it's a matter of do you trust us, and we'll certify it in non-disclosure, et cetera. And there's technological controls, and really it's just tactical data anyway, so who cares? But, the pushback was always security. We can't use anything outside the company because of security concerns. And fast forward about 18 years to 6 months ago, and we were having a talk with one of our clients about training on a particular set of technologies. And the client was a government agency, one of those government agencies that's in a nondescript building in a nondescript industrial zone. And I asked them, can you tell me about, your application? What kind of stuff are you doing? And the answer was, well, no, I can't actually, because it's covered by a security clearance, and you're not cleared, so I can't tell you what we do. And okay, fine. Can you tell me what you're doing with these technologies then, if you can't tell me about the application? He says, well, we're moving into the Amazon cloud. And to me, that was where the penny dropped that, gee whiz, the cloud is something that is not just an esoteric technology. If even top secret government departments are talking about putting their applications in the cloud, we should probably get used to doing it. And that is really the trend that I'm trying to point out here is that virtualization of commodity hardware, where applications run on a virtual machine that simulates a real machine, where we have virtual machines created and destroyed freely. That is just the way that things are done. And the vast majority of your applications should probably be running in the cloud, if not a cloud. The utility clouds that we're all familiar with, certainly Amazon EC2 is far and away the best known cloud provider. Microsoft Azure is hot on their heels. There are a number of smaller cloud providers, Rackspace, Joyent, DigitalOcean, and then some of the big names are getting into the cloud space maybe a little late, but trying to assert some influence like IBM, Oracle, and Hewlett-Packard. There are internal and external options. If you do want to run your own cloud, you can run it on CloudStack or OpenStack. But the long and short of it is that the cloud and the method of deploying applications into the cloud is here. Get used to it. It's just the way of deploying apps now. Why is that? Well, rapid development, flexibility, scalability, and just pure speed. I remember a number of years ago, I was involved in purchasing an enterprise requirements planning system, large enterprise app. And buying the software was one thing, but then buying the server was a whole other thing. Get 3 quotes and back and forth with the vendors for a couple of weeks, and finally finalize it. Get the $100,000 signed off or whatever, and then you bring in the server, and some IT guys got to assemble it, and that takes 2.5 days, and then they've got to load the software up on it, and by the way, they got to learn Unix, so there's some time there. And we used to, oh man, we used to, actually have an extended process of deploying a server. Now you want a server, I go on to Amazon EC2, or I go under Joyent or Rackspace, and click, click, click. There's my new server. It's up in 5 minutes. That's just the way we do it now. And there's a huge class of new developers that are just used to doing it that way. I've heard the sort of a couple of years ago, the healthcare.gov in the US started out as kind of a disaster, and then the Department of Health brought in a number of sort of external saviors, Silicon Valley types, to save the project. And basically what they did was they moved it to a cloud architecture. And, the comment was that, the free availability of EC2 is just the way things are now. And I think we need to embrace that in the enterprise. Key technologies in cloud-focused computing, Linux. Yes, Azure's out there. Azure can run Linux now, but the vast majority of cloud-focused deployments are in Linux. Things like the mean stack, Mongo, Angular, Node.js. The E is escaping me at the moment, but it'll come to me. Express, Mongo Express, Angular, and Node. And DevOps goes hand in hand with cloud. So the idea of getting cloud items out there in a hurry, getting software revisions out in a hurry is huge. Implications of the cloud, well, I mentioned security, and that's probably the biggest thing. Still, the biggest resistance to cloud deployments is security and data residency issues. And what you need to do is define and sort out your real security and data residency issues, not your imagined ones, but your actual real ones, and they may be different. Learn about the various cloud offerings, and if necessary, explore hybrid cloud and VPN solutions. Perfectly okay to host part of your application stack on an internal cloud, and all of the cloud providers now provide virtual private networks to treat the external cloud as an extension of your internal network. And so that way you can handle some of your data residency and backup issues. You still have to deal with the amount of data that's passing across the boundary, but that's something you can work with. And you need to learn architecture for larger applications. Along with the cloud-focused computing comes the idea largely of microservice architectures and scalability, which is often a little different to handle in the cloud. Okay. Containerization, another big trend. Started a couple years ago, but again, I find is really getting penetration into the enterprise markets right now. And, we're talking about things like Docker primarily. Although if you look around, there's also other container technologies and things like Solaris zones have been around prior to Docker, really the inspiration for Docker. But the idea of containers and containerized applications, to explain it, it's sometimes a difficult kind of concept to get your arms around. But it sort of goes back to the metaphor of the containerization of cargo handling. And to kind of understand this, you have to realize that if you went back to, I don't know, probably 1950, 1960, and went down to, the docks, wherever that's closest to you, maybe that's Montreal or New York or Long Beach or Vancouver. But if you went and looked at the shipyard, and you saw a boat that was coming in or a ship that was coming in and was being loaded or unloaded. Prior to about 1950 or so, you would have seen, individual cartons and cases and boxes and shipping cartons being loaded onto and off the boat. And this would take hundreds of longshoremen, hundreds of people really physically to go grab one thing and then go get it off the boat and drop it onto the dock and then move it around. Around about the 1950s, that was replaced by what was called intermodal transport and the idea of shipping containers as we currently know them. And the idea with a shipping container is I have a bunch of stuff I need to ship. I have a shipment of car parts or whatever. And instead of having individual cases of car parts or, oranges or apples or whatever, what I'll do is I will prepare a shipping container. And we have standardized sizes of shipping containers. There's a half container and a full container, etc., or half length and full length. And you load this all up at your place of business, and then you call your shipper, and they come by with a truck and take that shipping container and lift it and drop it onto a trailer adapter so they can haul it behind a truck. And then maybe take that down to the railway station where it gets lifted as a unit off of the truck and onto a train car. And then from there to the docks where it gets lifted off the train car as a unit and dropped in as, a 50-ton shipping container onto a boat and stacked, 4 high and sent across the ocean. And then the opposite ensues. And this was just a 100-fold improvement in labor efficiency and reduction in labor costs of loading and unloading. It also really revolutionized the shipping industry. We had standards. We had intermodal transportation. It really opened up international trade and commerce. That's the kind of thing that containerization is trying to do for software packages. And the idea is that you have a standardized container for a software package. And you deploy an app into the container. That container, then, that image becomes the deployment unit. And whether you deploy that onto your desktop or onto a small server, onto a large server, or onto a cluster, you have a standardized deployment, and we have standardized handling for it. We have standardized shipping. We have standardized storage. Okay, and then you can put your application into an image, host it in a central repository, and then running it is simply a matter of referencing that repository. The container image is already configured. we have a new host, we can spin up the app just by referencing the container image. There's no installation or configuration. The same way as we didn't need in the shipping industry 50 guys with good backs to go and rearrange stuff inside the boat. That's what containerization is about. Many of your application components and possibly some of your complete applications should probably be containerized. So that supports the building block approach. Containers, and there's various ways of going about it. Some people say that most containerized applications should be stateless, and there are stateful containers, etc. There's some options. Why do we do this? Rapid deployment is the big argument. The possibility of DevOps really being able to replace a single application component quite easily. And then if need be, go back to the old one. It's already pre-configured. And, the fact that we have configured the container offline means that we don't have to delay things online. And that speeds things up. So really flexibility and scalability. Your key technologies that you need to know about. Docker is the one, and Docker in its various forms, and it may not be Docker, but there is a Docker container standard, and many of the cloud providers now will use Docker images. Maybe not running under Docker, like if you use Amazon EC2 or use Joyent's container deployment, they're not actually running Docker, but they're able to use the Docker image so that they can use that standardized container. And so that's a technology stack that is necessary to know. And that, along with that, goes the idea of Docker Swarm, a cluster of Docker containers, registry, repository, etc. There are some container management and so-called scheduling applications like Kubernetes that are worthwhile looking into. The implications of containerization, what you need to do to respond to this trend. Learn the technology, certainly, but also learn to design componentized applications. That tends to go along with a microservice architecture. Containers tend to be built on top of cloud and tends to use DevOps techniques. So all of those things will be implied in this trend. Okay. DevOps. Big trend, not exactly new. People have been talking about DevOps for years, but it's been hitting the enterprise a lot more than it has been recently. And, what's DevOps? Well, DevOps is the application really of Henry Ford's ideas of production and operations technology and sort of building on Ford and Deming and Duran and Shingo and Takeda, and a lot of sort of production operations minds, but applying that to business processes and applying that to smooth the process of delivering value to customers through software. And the big impact of DevOps is to reduce the friction of deployments so that instead of deploying an application, on a quarterly basis or an annual basis, we can get to weekly, daily, hourly deployments, and probably equally importantly, the ability to back out deployments as well. So basically reduce friction, and that obviously makes us more responsive to our customers, makes us more nimble, reduces to some extent the requirements for big upfront design because we can kind of iterate and feel things out a little more. Really comes down to speed, efficiency, reliability, and customer service. But it's just not acceptable in 2016 to be deploying apps once a year. Okay, so what's involved in DevOps? Well, key technologies, DevOps, okay, we have development and operations. On the development side, and some of these span both actually, artifact management, Nexus, Artifactory, Arcava. Continuous integration tends to factor pretty heavily into DevOps. Things like test-driven development, insofar as it enables continuous integration. And I'll just mention this because this is, I almost had this as a trend in itself, but Git hitting the enterprise, Git for version control, reaching the enterprise. All of the tools that the cool kids are using these days are using Git underlying them. Anything that you might be using for JavaScript-based development. If you're using a package manager, there's Git under there. If you're using Nexus, if you're using, well, not so much Nexus, but if you're using Jenkins, probably using Git, you're probably having a sequence of repositories that we're working through. So Git is a big one that is key, and that's something that has certainly been out there in the open source world for a few years, but now is really becoming pervasive in the enterprise as well. And we've seen our Git course just take off in the past year or so. On the operation side, DevOps tends to get rolled in with cloud, tends to get rolled in with containerization. And also, one of the aspects of containerization in cloud, the idea of starting and stopping all these instances and having all these items to configure and control, deployment and administration tools like Chef or Puppet or Ansible, things that allow us to create scripted, repeatable deployments on remote machines become very important in DevOps. So that's another thing. And we have courses that are approaching all of those. The implications for you as a responder to this trend, learn the technologies, and that goes along with embracing the cloud, I think, obviously. Microservice architecture comes up again and again. DevOps always sort of points us towards having limited components that can be deployed independently, and that's just microservice to a T. Define your artifact handling. This may sound a little funny, but if we're going to treat software development and deployment as a process has a number of steps, and each step has some inputs and some outputs. And in software development, those inputs and outputs are artifacts. They may be a file, they may be a script or whatever, but you have to define what they are, and those define the little pieces of knowledge or input or output that move from one step in the process to the other step in the process. And the idea of artifact handling becomes very important in DevOps. And then even back then, step back a little bit from that and say, define your process. How do you actually create and release software? It sounds kind of silly, but a lot of people have kind of what I call a magical release engineering process where they may not have defined very well, or we may have a lot of human sign-offs, but what those people are supposed to be doing may not be actually written down. And that's something, if we're going to treat a process as repeatable and optimizable, we have to define what it is. And so you have to really do some serious thinking and reflection about your release engineering process and what the steps are and what value each step adds. Okay, so that's DevOps. In the mobile world, what's kind of been happening, mobile has been, kind of working in the background for a long time, but in the past couple of years, along with ubiquitous computing and the idea that really everybody has a smartphone, mobile first has really begun to emerge. So apps are designed first and foremost for mobile access. Okay, now sometimes this is natural, and we have location-focused applications like, hailing your Uber car or using your map. That's obviously sort of geared towards mobile. But mainly what we're seeing lately is that the vast majority of people's internet usage is actually through mobile devices rather than PCs. And if you think about it, everybody's got a smartphone. Every second or third person has a tablet of some kind. And it's becoming so it's a lot easier to just whip out your tablet or your smartphone and do a quick search or look up a catalog entry or place an order or get lunch rather than going to your desktop or laptop and executing a search. Now, that's taking a little while to get into the enterprise landscape, but it certainly is coming. Key technologies involved in mobile-first apps. The big thing is that as we move enterprise apps towards mobile, We have a real paradigm shift, and I don't use that word lightly, from the idea of having an application where we have our web app is a thin front end to an enterprise app that's running on the server. That has to change to a point where the mobile app, the device itself, is running a user interface application that happens to use some back-end technologies on the server side. And that's a whole different sort of architectural outlook on things. We've moved from really three-tier applications to almost peer-to-peer applications. And that's a whole different way of looking at things. So the mobile development aspect of it tends to be a lot of JavaScript, especially if we're doing web-based mobile applications. Java is still there if we're doing Android for the time being. Up and coming is the Swift language that we'll talk about, and Objective-C for actually developing on devices. For certain types of apps, if we know we have internet connectivity, responsive web development may be very useful. The idea that we can have a web application that's still accessed as a regular web page, but is actually a rich user interface application that adapts to the device that you're running it on. These apps, like I say, are really running an application in the browser or in the mobile device and then accessing back-end services on the back end. That means that RESTful services become key, and the understanding of what is a RESTful service and how to design RESTful services, and then how to design the backing stores for RESTful services becomes important. That back-end architecture, again, the whole RESTful service back-end tends to bring microservices along with it. And, well, if we're going to deploy mobile, there is the inevitable thought that in most cases, if we're going through the public network, we're going to have our back-end services hosted on a public internet-facing URL. And I bet that it's probably a whole lot easier and quicker to get a public-facing URL on the Amazon cloud than it is in anybody's internal network. I know certainly it is for us. I mean, I can deploy a public-facing URL in 10 minutes through Amazon, and it will take me a couple of weeks of approvals and negotiations to get it set up internally. So cloud becomes also extremely important in the mobile-first idea. Implications of mobile, well, developers need mobile development knowledge, and that is inevitably cross-platform knowledge. Unfortunately, we don't have uniformity of mobile devices. And, we don't want uniformity either. We'll talk a little bit about the bring your own device idea, but it's really not economical these days to provide, well, I suppose you could, but it's kind of silly to hand out a tablet or a mobile access device when everybody that walks in your door, each one of your employees is probably holding a $700 device in their pocket. So we need cross-platform knowledge that some of those devices are going to be Android, some are going to be Apple, and some are going to be something else. Server's backend becomes primary, and again, that brings with us REST and microservices and so on. So the architecture of applications change a little bit. We're seeing less and less interest in sort of traditional Java Enterprise Edition, insofar as, doing Java server pages or servlet-based or JSF applications is starting to dwindle. Java EE makes a tremendous back end for services. Don't get me wrong there, and designing RESTful services in Java EE is an excellent way to go. But the user interface technologies seem to be fading a little bit. Along with this, sort of mobile first is the explosion of enterprise mobile apps. And again, this is a case where mobile apps and apps running on phones really have been around since 2007 or so. But we're starting to see even internal enterprise sort of bespoke applications are beginning to be geared towards running on mobile devices rather than, something we have to go back to our desk to use. Why is that? Well, every single one of your employees is probably carrying a mobile device. Okay. I mean, yeah, there's exceptions out there. I know, my wife is clinging to her non-smart QWERTY texting phone until it falls apart. But that's just because she's used to it. But at the same time, she hasn't used a PC in years since she got an iPad. And we probably have all these mobile devices around. People are used to using them for other applications. They're going to start saying, well, what if I had access to the enterprise data? What if I had access to those sales reports? What if I had access to our product catalog? What if I could book a meeting room? What if I could, place an order right on my phone? And at point of sale, which is everywhere. I'm not a huge fan of the Apple Store, for instance, but one thing you got to hand it to them: they don't have a cash register. You don't have to walk to the back of the store to buy something. Every employee in there is walking around with an iPhone that's got a credit card reader attached to it, and point of sale is everywhere. There's no reason we can't embrace that in the enterprise as well. So why do we do that? Speed, flexibility, efficiency, and customer service. Key technologies for enterprise mobile, mobile web development. And when I say web, when we're talking enterprise applications, this is a real great application where, especially if we have people in our environment hooked up to our network, it's a great scenario where your mobile web applications work, where we probably don't want to have things loaded onto the device. We want to have responsive web development and JavaScript-based applications, and so that really works well. So things like Angular, things like Bootstrap, things like Angular UI, things like Ember.js, etc. And responsive design, again, because we have uh, sort of a variety of devices that we're using. And again, the service backend, the whole architecture of treating applications as a user interface application talking to a service-oriented backend. And that brings along microservices and cloud with it. Okay. Implications of enterprise mobile. Well, number one, define your device strategy. And I'm going to suggest that we used to talk about bring your own device as a thing, and something that you might choose to save a bit of hardware investment. I think what you'll find now is that, especially if you're hiring, younger people, the archetypal millennials, they already have the laptop that they like, and they already have the phone that they like, and they already have the tablet that they like. And why should you go and buy another tablet to give it to them? So bring your own device is going to be default, and that is going to then influence your development strategy. For mobile apps, you can have web-based development or native apps and hybrid, somewhere in between. We'll talk a little bit about Apache Cordova in a minute. Examine your security policies, and how do you work out your security policies. This will determine or influence anyway what sort of infrastructure you need to have. Are you going to allow on-premises employees to connect their devices to your network? And do you need special network or special subnets for that? Do you need to have special hardware or any kind of special support for connections to that? Cloud, if you end up needing externally accessible URLs or externally accessible websites, it's probably a lot easier and quicker to provision through Amazon than to make a backend available through your regular operations. And that's actually kind of a signal about IT operations and how flexible they can be or how flexible they need to be. But the fact of the matter is that if you want to present an API to the outside world, probably faster through Amazon or Rackspace or Joyent. And we see discussions sometimes about rogue IT, and that's what people are talking about is developers and managers deciding to deploy through public cloud rather than through the internal operations. Drives IT operations crazy, and a lot of that is reasonable, but at the same time, it happens because people have a job to do, and people need to get services provided, and they need to get things done, and they will act in the best interest of the organization to get things done, even if that means brushing aside a part of the organization. So that's a signal that you need to be a little more responsive. Yeah. Swift programming language. Swift is something that's starting to make waves, I guess. On the development end, you probably, if you're developing mobile apps, you've had Swift in-house for a bit. It's a new programming language that was introduced by Apple in 2014. It's usable across all Apple devices and OSs. So from everything from an iPhone up to the Power Mac can use the Swift language. It was intended as a replacement for Objective-C. But here's what's interesting. In the past few months, there's been some interesting movements on the Swift programming language, and that's why I put this on this IT trends, because I think it's worthwhile keeping an eye out for it. As languages go, I'm a bit of a computer language geek. I managed to design and create a computer language back in the late 80s for the Unix operating system, and ever since then I've been interested in language design. And Swift is pretty good, as a language goes. It's new. It's not overly esoteric. It looks pretty practical. It combines some good features of Python and C, and it's a pleasant enough language. But the one knock against it was it's only Apple devices. Okay, now I know Apple thinks they want to rule the world, and they may end up yet doing that. But most of us don't want to, put all our eggs into one basket. But they made this interesting decision to release it to open source under the Apache software license in December of last year. And as a result of that, it's now being adopted for other things. There are, in fact, IBM has adopted Swift as one of its official languages to support in the IBM cloud. So it's making its way to the server side. I have recently seen some rumblings about Google adopting Swift as the language of their Android device. I think that's probably more to do with the impending negotiations with Oracle over the penalties for losing the Java lawsuit. But there is some talk that it could become the default language for Android applications. There is an implementation for Microsoft's Common Language Runtime. So probably worthwhile keeping an eye on it. And certainly if you are having developers supporting or developing for Apple devices, in a lot of ways, Swift is nicer and easier to program with than Objective-C, and I think it's fair to say, given the importance that Apple places on it, that newer APIs and newer functionality is probably going to be preferred in Swift rather than Objective-C. So keep an eye on Swift. I think we're going to be hearing a lot more about it in the next few months, and certainly at WebAge we have some training courses upcoming on Swift. Okay. Hybrid mobile apps. What are hybrid mobile apps? Well, the idea of a hybrid mobile app, and this kind of rolls in with ubiquitous computing and enterprise mobile and mobile first apps. The idea with a hybrid mobile app is that we write an application using JavaScript that is basically a web page. Okay, but then we take that. Oh, sorry about that. There's awful noise out there somewhere. But then we take that and run it through some tools, and the one that we typically use is Apache Cordova. And that packages that web app for deployment to a device, to a native device. And that can be any device. And the great thing about it is you can take the same web app and deploy it, load it into an iPhone, an iPad, a BlackBerry, an Android device. If you happen to have the one of the three Windows phones that are out there, you can deploy it to that as well. So it's a relatively simple way to support those enterprise mobile apps. Not quite the same capabilities as a real native app, but 90% of the time, we have all the capabilities that you would want in a hybrid mobile app so that your developers don't really have to learn a new language. They don't have to learn Swift. They don't have to learn Java. You can write it in JavaScript. And we get portability across devices. So that's really nice. And, like I say, 90% of the time, these are good enough mobile apps, including things like geolocation, including access to the camera, including local storage. Most of the time, that's all you need. And the common usage is Apache Cordova. Key technologies involved in hybrid mobile apps: well, JavaScript, responsive web design, front-end frameworks or JavaScript model view controller frameworks, and the popular one right now is Angular, and Angular for the MVC and Bootstrap for the layout. Again, that goes with the RESTful backend. And so, we have the actual mobile web application architecture. And I was just mentioning that's one of the things that I think we at WebAge do a little bit differently. Because I haven't seen, I'm a little biased, obviously, but I haven't seen anywhere else um, a course in the overall mobile architecture. And we have kind of, I think, a unique offering in mobile architecture, as well as just the programming. Everybody and their brother will teach you how to use Objective-C, but we actually talk about how to build a real application. So have a look at that. And again, Git. Anytime we have JavaScript, okay, anything that is involved in JavaScript or the Node Package Manager or what's the Bower Package Manager, inevitably is tied up with Git. And so, any sort of JavaScript-based development you do, you're going to have to get familiar with Git as well, so that you know how to track the packages and track the development of the system. And, to some extent, get familiar with GitHub, although it's kind of different from Git. So, all these become key technologies. The implications of hybrid mobile apps, well, define mobile device policies, because even though we have portability across devices, you still want to know, what kind of devices are we supporting? Are we supporting phones, tablets, or larger devices, and to what extent do we support them? Certainly learn the technologies. The architecture, again, needs to support RESTful services, and designing that back-end architecture is a whole different thing. And it, again, goes along with cloud access. It's inconvenient to have your devices going through a separate Wi-Fi port. So you probably want to get your hybrid mobile apps presenting API on the public internet. And so cloud becomes important in that scenario again. Apache Spark. I did promise we'd talk a little bit about big data. Apache Spark is an upcoming trend, fast and general engine for large-scale data processing. And the difference between really Spark and Hadoop is that Spark focuses on what's called stream-oriented processing, where you define your processing as a sequence of steps where smaller pieces of data can be passed from step to step, and it's a sequence of processes. There are high-level APIs in Java, Scala, Python, and R. It's another approach to big data. Spark and certain certain users of Spark for certain classes of problems claim that it's significantly faster than traditional MapReduce programming or batch programming with Hadoop. And the implications, you need to have some familiarity with data science. We need to learn the technologies. Interesting thing, though, I've seen another trend, and again, I was considering setting this up as a slide in itself. But the idea that big data, although we all want to be involved in big data because it's sexy and kind of a nerdy kind of way, um, a lot of problems really are not big enough to justify big data. And at the same time, our traditional database technologies and traditional processing technologies are growing with the hardware that we're running them on, such that we can do queries on multi-gigabyte databases with a traditional database, Oracle or PostgreSQL or what have you. And in a lot of cases, that's going to be faster than trying to parallelize and split and re-architect a data problem. So, keep in mind that what used to be a big and intractable problem for a database has probably been crushed into oblivion by just the advance of hardware over the past 10 or 15 years. I remember years ago, I used to be in manufacturing, and we often had requests as databases were coming out, for traceability, and people would say, we should collect all the data that we generate in the manufacturing process, and we had conversations where we'd say, well, yeah, that's fine, but we make 100,000 units a month, and we collected a couple of kilobytes of data on each. We could be generating, I don't know, 20 megabytes of data per month. And what are we going to do with all that? How are we going to handle it? Well, guess what? In 2016, 20 megabytes of data is 1/50th of the RAM memory in your phone. So a lot of the things. I guess what I'm getting to is that a lot of us are not really doing big data problems. Okay, so we feel free to attack it with traditional data analysis techniques, and we don't necessarily all have to learn Spark and Hadoop. Anyhow, Internet of Things. I put this on here just because everybody mentions it as a trend in 2016. This is the year of the Internet of Things. Now, people have been saying this is the year of the Internet of Things for at least 5 years, and I'm not quite sure if it's true yet. But what is the Internet of Things? Well, the idea of the Internet of Things is that computing is ubiquitous. And everything has a microprocessor in it. Okay, if you bought a washing machine or a stove in the past 5 years, it has microprocessors in it. So computing is everywhere. It's actually cheaper and easier now to write software than it is to create circuits to control things. Okay, even radios and TVs are all software now. So computing is ubiquitous, so is connectivity. Internet of Things says, what are the possibilities if those devices can communicate? Because, as we've had connectivity grow out, and we have cellular connectivity, and we also have Wi-Fi just about everywhere, why can't we have a gateway from Bluetooth to Wi-Fi, etc.? So, what can we do with devices that can talk? It's how useful is it to have my fridge on the internet? Well, that's the problem. How useful is it to have my fridge on the internet? And a lot of the hype around Internet of Things is that it's possible, and sort of traditional companies like Cisco and IBM are looking for applications to expand their influence and expand their sales possibilities. So we see a lot of discussion of the Internet of Things. To some extent, it's still a solution looking for a problem. The key technologies involved, the message queuing, or MQTT is message queuing for the Internet of Things. Cloud, if we're going to have connectivity, that data that's generated has got to go somewhere. Embedded computing becomes important. As far as implications go, I have to tell you, despite all the hype and the fact that you'll see Internet of Things listed on every list of trends that's around, I don't think we know what it's all about yet. Okay, it's probably not about fitness tracking, but it's hard to say. If you look at things like the Consumer Electronics Show, there's a lot of discussion of the Internet of Things, and a lot of it was, you put this wristband on and it tracks how many steps you take and how many glasses of water you drink. Well, how useful is that? I'm not convinced. I don't have a Fitbit. My daughter wants one, but I can't see what the use is. Having said that, I I go play tennis, and if that's going to save me a couple $100 a year on my life insurance by putting on a wristband to prove that I go play tennis, well, maybe that's worthwhile. Uh, the implications that we have yet to figure out about Internet of Things are things like privacy and security, particularly privacy of data. There's some discussion. Example, insurance companies, auto insurance companies. There's a few of them now that are promoting tracking devices that plug into the onboard diagnostics port of your car and log data and periodically drop that data up through the GSM network to central servers to judge whether you are accelerating or speeding or stopping quickly, etc. And where you're driving, because what neighborhood you drive through can impact how likely it is that you have an accident or that your car gets stolen. Well, yeah, that might be able to save you some bucks on your insurance, but are there privacy issues around tracking where you go and who can access that data? And that's yet to be sorted out. So, there's a lot of possibilities and security. The one thing I'm going to say about the Internet of Things, though, is that the things that we can put on the Internet are becoming exceedingly cheap. So, if you look at a Raspberry Pi microcomputer, it's got a gigabyte of memory, a 1 gigahertz quad-core processor, and an SD card, and Bluetooth and Wi-Fi and everything, and you can connect sensors to it. And it sells for $35. Arduino boards can be had for $5 to $15 on various internet. So, the Internet of Things is kind of interesting. I'm just going to suggest that even though we don't know what it's good for, it probably is worthwhile if you offer your developers, here's a free Raspberry Pi or a couple Arduino boards. You might drop $100 on miscellaneous stuff and say, try and do something interesting for the organization, something interesting from an enterprise point of view. You probably get some interesting results. And that's as much as we can say about the Internet of Things right now. The last thing I'm going to touch on, just because I want to wrap up, hopefully with a couple of minutes for questions, is the idea of Agile and DevOps being not just for software. Well, it wasn't for software initially. It was actually the process-oriented and lean thinking that came out of production and operations management. But it can also be applied to business processes. Okay, so we've seen surveys lately that show that things like, the trappings of Agile software development, task boards, Kanban, etc., are actually being used for general process management. And there's been a couple of movements of major applications. The one that stuck out to me happened last year was Jira. Atlassian Software was repositioned their Jira package, which was always a bug tracking and ticket management package. They have repositioned that as a generalized workflow and customer service support package. And I think that's kind of interesting because it suggests that some of these learnings from process management and Agile software development have reached into other business processes and workflows. And it's kind of funny. I always thought that the production and operations would be the path that got lean thinking into generalized business processes. But what kind of happened was that in the past 15, 20 years, manufacturing declined in importance and software increased in importance, and IT increased in importance. And IT dragged production and process and operations knowledge into the office setting and is now spreading it out through the rest of the business. So that's interesting. So key technologies there, Kanban, Kaizen, Six Sigma. I got a typo there. It should be Six Sigma, not Sis Sigma. Lean thinking, lean operations, and implications of that. Well, I guess the implications are we need to think in terms of process and artifacts. And the one thing that you have to think of, and if you're going to examine business processes, is the fact that it is a business process. Never ceases to amaze me that a lot of business analysts that I talk to, if I say, what's the process for dealing with an order, let's say, they'll start talking about when we go to this screen and we do this, this, and this. And we really need to sort of get back to that process thinking where what's the trigger event that starts the process? What are the discrete and describable artifacts or pieces of information or physical artifacts that move between steps in the process? So that process-oriented thinking is difficult to come by, and we do offer a couple of courses in business analysis and business process management. So business analysis is not limited to software is basically the point that I want to make as far as trends. So kind of wrap up, that's where we see major trends in IT. As far as our offerings go, these trends hit just about every course that we offer in terms of technologies and architecture and business analysis and system analysis and enterprise architecture. So I'm just going to refer you to our website, www.webhsolutions.com. And we'll also point out that we have an excellent, I think, resource area there. We call our knowledge base. URLs here, www.webhsolutions.com/knowledge base, and well worth checking out. And you can sign up for notifications when we post new articles, but I think you find a lot of useful things there. Right, and I'll invite you to ask a few questions if you'd like. Let me just get my questions panel up. Happy to answer any questions that you might have. Let's see. Any thoughts on where... Oh, any thoughts on where Spring Framework stands? Okay, good question. Spring Framework is becoming, Pivotal has been repositioning Spring to be the foundation of the back end for microservice architectures and for building Java-based backends for applications. And so Spring has sort of moved a little bit away from the sort of Java Enterprise Edition. It never was really huge on Enterprise Java Beans or anything like that, but certainly moving away from the sort of more traditional servlet JSP type front end. But has becoming a very popular sort of standalone server framework and standalone method of building back-end architecture. So, Spring, I will confess, we had some discussions when EE6 came out as to whether Spring had any relevance still. But Pivotal has done a great job repositioning Spring as an independent sort of microservice-based architecture. So Spring is viable, and we're seeing a lot of interest in Spring Framework. Okay, we mentioned training for Angular Bootstrap. Any training plans for Polymer or web components? Not familiar with those frameworks right now. I will confess I'm not the stream lead for mobile, so I'm probably a little out of the loop on that. But what I would suggest is if you have a specific need, talk to your sales rep and let us know. I mean, what we do fundamentally at WebAge is we learn new technologies in a hurry, and we write down what we learned and condense and compress that so that a busy working developer can get most of the benefit of that in a short period of time. So, if you ask about a framework that we're unfamiliar with, our only question is, how many do you need to get trained, and we'll see about doing it. So I'm not familiar with Polymer or web components right now, but that doesn't mean we can't do it for it or we can't help you out. So encouraging to talk to your sales rep. I have another question. Any recommendation for cloud computing training? Yeah, we have, of course, a lot of offerings in cloud computing. Really, it boils down to what are you going to do with it? Are you interested in just the deployment end of it? We have a really great introductory course, Introduction to Cloud Architecture, that explains what cloud is and gives a sample of technologies. As far as for developer, yeah, again, that's probably a more deeper cloud architecture course. We have a number of different language trainings that we can offer. We offer training in Java, in Node.js, in RESTful services, MongoDB. There's also our DevOps offerings are geared towards making sure that both developers and operations have enough knowledge to work together and understand things about containerization and virtualization. And we also have some specific training on the Amazon cloud infrastructure. So, the simple message server or simple message queue and S3 storage and EC2 compute. So, yeah, we can help you out with that. Again, have a look at the website and have a chat with your sales rep. Okay, question. Good one. Should go to general cloud or AWS specific? I'm not sure if you're asking about our catalog, but yeah, realistically, part of me says stay generalized because you want to have options open, but between you, me, and the fence post, probably 95% of cloud deployments are on Amazon EC2. So, not you won't go far wrong studying Amazon specific items. Yeah. Presentation will be made available. You'll receive an email probably in a couple of days when we post the presentation and the recording on the website. So that will be, you'll get an email in a day or two. All right, and with that, we're about 5 minutes past 2 o'clock where we were trying to end up. So I will thank you very much for your time and keep an eye out for future webinars. And I sure hope we can help you out with your training and mentoring requirements. Thanks very much. Bye.